Well, hello, calculus students, pre-calculus students, and especially seekers of general truths. In this video, we will solve this problem here, cosine of 22.5 degrees, and we will find an exact answer. So I know you can look this up and type it into your calculator. I know you could probably Google some crazy formula online, but this video is especially for those seekers of truth because I want to show you how we can work through this methodically, even if you can't understand everything, every single step by yourself. It is important that you work on these and take it as far as you can whenever you're faced with something difficult. So a little bit of a hint before we begin here, that 22.5 is exactly half of 45 degrees. Okay, so if you have 45 divided by 2, then you get 22.5. Now 45 degrees is a special angle, so if we can sort of convert this expression into some combination that uses cosine or sine of 45 degrees, then we can try and find this answer. Okay, so what I'm going to do is something a little bit unorthodox. I'm going to ignore the specific numbers, and I'm just going to focus on this problem here. What if I had a function or an expression cosine of 2 theta? What would that be equal to? Okay, and how can I expand it to get theta alone? Okay, so first thing I would do is say cosine of theta plus theta. And so separating those two. And then using the cosine of a sum, I'll put on the margin here, that I'm using the cosine of a sum. Okay. Then I can expand the statement into cosine of theta, okay, minus sine of theta, sine of theta. I really should have parentheses around all these thetas. And then that simplifies to cosine squared theta minus sine squared theta. Okay. And I know that like this right now looks kind of like the Pythagorean theorem, the Pythagorean identity, but it's not quite, right? If this was equal, if this was a +1, then we would really have something here, but it's not quite, okay? And so here, let's kind of engage with the problem a little bit now that we've got an expression. And keep in mind, our goal here is to solve for the cosine of theta. So in our specific example, theta is equal to 22.5 degrees. Okay, and so if we look at the expression here, cosine of 2 theta, well, that's just cosine of 45 degrees. And that's equal to cosine squared of 22.5 minus sine squared of 22.5. Okay. Cosine squared 22.5 minus sine squared of 22.5. So, and don't forget that this is what we're solving for, right? This expression right here is almost what we're solving for. We just need to be able to get that by itself, okay? Cosine of 45 degrees, we know what the answer to that is already. We know that this is going to be equal to root 2 over 2. Okay? Cosine squared of 22.5, I'm going to leave that alone just because that's what I'm solving for. This is like a variable. But sine squared of 22.5, well, sine squared is not really a special angle. 22.5 is not a special angle either. So I have to do something to that, right? So I'm going to convert it using the Pythagorean identity. So we're going to subtract. Sine squared is equal to 1 minus cosine squared of 22.5. Okay. So this is the Pythagorean identity. Okay. And again, my goal here is to isolate cosine of 22.5. And so at this point, we got something here. It's going to be a little bit messy, but we've converted everything into 22.5 and cosine. Okay, so now I'm going to do some simplifying. So on the left side, I still got root 2 over 2. This is, I'm going to distribute that negative sign, so that's going to give me negative 1 plus positive cosine squared 22.5. Okay. Going to combine my like terms, and that gives me 2 cosine squared of 22.5 degrees minus 1. Okay. And now we're going to add 1 to both sides. So root 2 over 2 plus 1 is equal to 2 cosine squared 22.5. Okay. A little bit more cleanup here. So combine these two together. That gives me root 2 plus 2 over 2. So again, 1 is just 2 over 2 is equal to 2 cosine squared of 22.5. Divide by 2, I get root 2 plus 2 over 4 is equal to cosine squared of 22.5. Okay. And then I can take the square root of both sides, and that's going to give me, it's going to give me something that looks kind of crazy, right? So it's going to give me root 2 plus 2 over 4, and I'm putting an enormous square root around the whole thing. So now I have a square root within a square root that's going to give me the cosine of 22.5. Okay, so, and I know this looks really weird and crazy, but it is an exact answer. We can actually use basic numbers, the square root of 2 plus 2, right, all of that divided by 4, and then the square root of that to give us the answer that we're looking for, which is whatever, which turns out to be is the cosine of 22.5 degrees. Okay, so there you have it. Now this is the final answer. But I want you to also take away kind of the bigger ideas. It's like, how do we do this, right? Well, this seems untenable, unusable, unsolvable. But if we start out just thinking about how this relates to the work that we've been doing, and we kind of sneak up on the problem a little bit. We start with cosine 2 theta and do a little bit of work with the trig identities in order to get to an expression that we can solve. As always, thank you for watching. Ask questions if you need it, and have a wonderful day.